Good evening, everyone. Today we're going to start probability distribution of a random variable. Here we have to construct a probability distribution table with given x and p of x. So x and p of x will be defined and we need to write all the possible probability of x. Now before I start it, let me just explain the base of checking whether the given table is a probability distributive function or not. In order to see whether the given table is a probability distributive function, we need to see for two conditions. First one, see whether the probability value is between 0 and 1. Every probability value between 0 and 1. Then the total probability must be 1. So as I said, x would be defined in the question, p of x would be given in the question. So the first few questions where x and p of x would be given, we need to check whether the given table is a probability distribution of a random variable. So for that, see whether every probability value lies between 0 and 1. 2, see whether the total probability is 1. If any one of the two conditions is not satisfied, then it is not a probability, it is not a clearly defined a probability random variable. Now, look at the exercise questions. Question number 1, x given, p of x is given. So when x is 0, probability of that is 0.4. When x is 1, probability is 0.4 again. When x is 2, probability of 0.2. Now here, when you see every single probability value lies between 0 and 1 only. So this is a well-defined probability then. 2. See whether the total probability is 1. The total probability is also 1. So both the conditions are satisfied. So this one is a properly defined probability distributive function of a random variable. Next, if you see when x is 3, p of x is minus 0.1, which is negative. And therefore probability cannot be negative, so this is not a properly defined probability function. Third one, p of x values, p of y values lies between 0 and 1, but the total is only 0.9, which is not equal to 1, hence this is also not a probability distributive function. Fourth one, if you total it, it's 1.05, which is not equal to 1, hence this is also not so. So in the third and fourth, the second condition is not satisfied, first condition is satisfied. Question number 2. A urn contains 5 red and 2 black balls. 2 balls are randomly drawn. X represents number of black balls. What are the possible values of x? And is x a random variable? What are the possible values x? They are not asking you about p of x here. Out of 7 balls, we are asked to draw 2 balls. And both the balls, and x indicates the number of black balls here. So 2, let x represents number of black balls. Now, out of 2 balls, none can be black, 1 can be black, or both can be black. So x indicates the number of black balls. Both the balls cannot be a black ball, or 1 out of the 2 can be a black, or both can be black. So these are the possible values of x now. Now let us go one step ahead and find the probability of this. And I'm going to go with replacement. I'm going to do it with replacement, though it is not asked in the question. So P of x here. So that means I'm going to draw 2 balls in which both the balls are not black. Right. Now what is the probability of drawing a black ball? Out of 7 balls, 2 are black. So probability of drawing a black ball is 2 out of 7 chances. Probability of not drawing a black, which is black complement, or if you want you can write it as a red also, which is 5 by 7. As there is no other balls in the bag, there is only black and red. If you are not going to take black, it will be red only. So 2 by 7 and 5 by 7. The first one x is 0, that means both balls are not black. So that means both are red balls. So P of red, red, red. You can write it as P of red into P of red or P of red, red. So the answer for that would be 5 by 7 into 5 by 7. Now when x is equals to 1, which means one of the ball is a black ball. So that could be black, red, probability of black, red, probability of red, black, which is 2 by 7 into 5 by 7 plus 5 by 7 into 2 by 7. Next one, both are red, both are black. So black, black, which is 2 by 7 into 2 by 7. Now once you finish constructing the probability distribution, check whether the total probability is 1 or not. So what do we get? 25 by 7 square plus 20 by 7 square plus 4 by 7 square. So 45, 49 by 7 square. So that is one only. So this is a properly defined probability distributive function. Question number 3. Let x represents the difference between the number of heads and the number of tails. So they told you what they want you to take x as. X here represents the difference between the heads and the tails. When a coin is tossed 6 times, when a coin is tossed 3 times itself, the outcome is 8 here. So here it would be multiple 2 power 6. So writing them is not a possible way. And they don't want us to write it either. They only want us to find out the possible values of x. So what does x represent here? The difference between the number of heads and the number of tails. X represents difference between number of heads and number of tails. Let's assume heads as m event. Let's assume tails as n events. Okay, let's assume m number of tails and m number of heads and n number of tails coming. Okay, so x, I can get all 6 heads and I'm not getting tail at all in that case because a coin is tossed 6 times only. All 6 times I'm getting head here. So x represents modulus of m minus n here, which is 6 minus 0. First case where all 6 are heads, no tail. So x is equal to 6. Next one, x is equals, I get 5 head and 1 tail. So that is 4. Then I get 4 head and 2 tails. So that is 2. Then I get 3 head and 3 tails. So x is 0. And then onwards I'll decrease m and increase n. Anyway the outcome will be the same only. I'll be getting 2, 4, 6 again. So it doesn't make difference whether it's modulus of m minus n. Since it's modulus, whether it's m minus n or n minus m, it's just one and same. So we stop it here. So possible values of x is 0, 2, 4 and 6. Question number 4. Find the probability distribution of number of heads in 2 tosses of a coin. Probability distribution of number of heads in 2 tosses of a coin. So x represents number of heads in 2 tosses. So now probability of getting a head in one toss is P of h. Probability of getting a head in one toss is P of h, which is 1 by 2. Probability of not getting a head, which is h complement, which is nothing but getting a tail in one toss, is also 1 by 2. Now here x represents the number of heads in 2 tosses of a coin. So x can be 0, x can be 1, x can be 2. I can get both the tosses as non-head tail. One is head and one is a tail, and both as head. So P of X here. When X is 0, X indicates the number of heads, and X0 means no heads. So both are tails here. So that is 1 by 2 into 1 by 2, which is 1 by 4. Next one, X is 1, one is head, the other one is tail, plus tail head. So which is 1 by 2 into 1 by 2, 2 times. So that is 2 by 4. Don't simplify, keep it as it is because we need to add it to 1. Now when 2, then both are heads here. So which is 1 by 2 into 1 by 2, which is 1 by 4. Now check whether it adds up to 1. It is. 1 plus 2 plus 1 is 4. 4 by 4 is 1. So total probability is 1. So that's for the next subdivision. The number of tails in a simultaneous tosses of 3 coins. Previously it was 2 coins, here it is 3 coins. So X represents the number of tails here. Fourth, subdivision 2, X represents the number of tails in 3 tosses. So probability of getting a tail is 1 by 2 in one toss of a coin. And probability of not getting tail is equal to probability of getting head is also 1 by 2. So here X when 0, X is 1, X is 2 and X is 3. 0 means no head, no tail at all. So everything is head, which is 1 by 2 the whole cube. Next one. Now when X equals to 1, which means one is a tail, the other two are heads. And there could be 3 chances to this. There will be 3 chances to this because the tail's position I can change it in 3 ways. So this will be 3 times 1 by 2 the whole cube. When X equals to 2, that means I'm getting 2 tails. I'm getting 2 tails and 1 head. Well, if you want to know, put all the different arrangements. There also you get 3 events. Will be 3 outcomes in which we get 2 tails. So 3 again, which is also 3 times 1 by 2 the whole cube. Now the last one is getting tail in all cases, which is 1 by 2 the whole cube. So if you simplify this, this is 1 by 8, this is 3 by 8, this is also 3 by 8, this is 1 by 8, and add everything, you will get 1 by 1. So number of heads, third case, find the broad distribution of number of heads in 4 tosses of a coin. So X represents number of heads in 4 tosses. So X is 0, X is 1, X is 2, X is 3 and X is 4. So when X is 0, so here probability of getting a head in one toss is 1 by 2. Not getting a head is also 1 by 2. So here P of X would be no head at all 4 are tail. So probability of tail, 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 which is 1 by 2 to the power of 4. Next it's 1. So that means 1 head and everything else is tail. There would be 4 ways of writing this because head can appear here or here or here or here. So there are 4 ways of arranging it. So 4 times. So this will be 4 times 1 by 2 to the power of 4. Now when X is equal to 2, that means 2 times head and remaining 2 is tail. So P of head TT. And there will be 6 arrangements to this. There will be 6 arrangement to this. So this will be 6 times 1 by 2 to the power of 4. When then if it's 3, if it is 3, it would be P of head head and tail. There will be 4 arrangements to this. So this will be 4 times 1 by 2 the whole power 4. And when it is 4, that means all are head, which is 1 by 2 to the power of 4. Now this is the probability distribution of C, whether the total is 1 or not. Okay, fifth question, subdivision number 1. Find the probability distribution of number of successes in 2 tosses of a die, where success is defined as a number greater than 4. So, you're tossing a dice twice. If you get 4 and above, above 4, it is considered as a success. If you get above 4, it is considered as a success. So, X indicates the number of success here. X indicates the number of success. In 2 tosses. So what is success? Getting a number greater than 4 in a single throw of a die. So that means 5 or a 6. So if I get 5 or 6, then I consider as I won the game. So 2 out of 6 chances. So then failure is what? 4 out of 6. So this is 1 by 3 and this is 2 by 3. Okay. Now what is X defined as? I'm tossing as 2 times, so I'm not getting success in both the toss. I'm getting success in one of the toss. I'm getting success in both the toss. So X is 0, 1, 2. P of X defines the probability of my success. X is 0, that means I'm in both the tosses I failed. So it's failure, which is 2 by 3 the whole square. Next means 1 success. So that means success and a failure plus a failure and a success. So that is 1 by 3 into 2 by 3 into 2. This is not square, it's into 2. Next it's 2. So that means both the times I succeeded. So that is 1 by 3 the whole square. So this is fifth first subdivision. Second case of fifth question. 6 appears on at least one die. So success here is getting 6 even one time. So getting 6 even one time is considered as a success. So this question, I'm going to do it in a normal way first. And I'm going to do the way as I've taught you in the first 5 sums. So let me do the normal way. Success is getting 6 at least once. So that means 6, 1, 6, 2, 6, 3, 6, 4, 6, 5, 1, 6, 2, 6, 3, 6, 4, 6, 5, 6 are all the outcomes in which we get 6 once. And then 6, 6 is an outcome where we get 6 twice. So getting a 6 at least once is considered as a success. So probability of success is 11 out of 36. If you take 2 tosses together, 2 tosses, it's not like how we did the previous questions. Now this is success here. So what is failure then? Failure is 1 minus of that. 1 minus of 11 by 36, which is 36, 11, 25 by 36. Now, over here, X represents the number of success. X is the number of success. And I've already considered 2 tosses. So X is 0, 1. That's all. Success or no success. So P of X would be no success, 25 by 36. Success, 11 by 36. So this is when you take tosses together, when you write all the outcomes. Question number 6. From a lot of 30 bulbs, 6 are defective. From a lot of 30 bulbs, which includes 6 defective, a sample of 4 bulbs is drawn. At random with the replacement, find the probability distribution of number of defective bulbs. X represents the number of defective bulbs in 4 bulbs. X represents number of defective bulbs in 4 bulbs. So X can be 0, X can be 1, X can be 2, X can be 3, X can be 4. So X0 meaning all the 4 bulbs that we are taking are not defective. Now what is probability of taking a defective bulb? 6 out of 30. This is 1 by 5. Probability of not a defective will be 4 by 5. So P of X would be X equal to 0 meaning no defective one at all. So all the 4 bulbs are good bulbs. So D complement, D complement, D complement, D complement, 4 by 5 to the power of 4. X equal to 1, which means 1 is defective, the remaining 3 are non-defective. There will be 4 chances to this. So 4 times 4 by 5, the whole power 4. Since it's with replacement, we don't need to use combination. 4 by 5, the whole cube into 1 by 5. Then X is equal to 2, which means we get 2 defective and 2 non-defective. As again, there will be 6 cases to this. So this will be 6 times 4 by 5 the whole square into 1 by 5 the whole square. Then X equal to 3, which means 3 defective and 1 non-defective. So this will have 3 cases, which is also be 3 times 1 by 5 the whole cube into 4 by 5. Last one, all are defective. So that is 1 by 5 power of 4. So this would be 4 times, and correct here it's 4 times. 7th question, a coin is biased. This question is important. A coin is biased so that the probability of head is 3 times as likely as a tail. So according to the question, it's a biased coin. Probability of getting head, it's 3 times probability of getting tail. In general, total probability is always 1, whether it's a biased or an unbiased event. So probability of getting head is 3 times probability of getting tail. So 3 times P of T plus P of T equals to 1. So 4 times probability of getting tail equals to 1. Probability of getting tail is 1 out of 4 chances. Therefore, probability of getting head would be 3 out of 4 chances. Now, X represents the number of tails. X represents the number of tails in two tosses. So, X can take the value of 0, 1 and 2 as usual. So, P of X would be, both the time I am not getting tail, so it is head. So, 3 by 4 into 3 by 4. Then I am getting head only once and there will be 2 chances to this. So it will be 2 times 1 by 4 into 3 by 4. And third one is getting tail in both. So TT, which is 1 by 4 into 1 by 4. Question number 8. A random variable X as the following distribution. So X and P of X is already defined and given to us. Only thing, P of X have a missing variable K. And we know that total probability is 1. So sigma P of X must be equal to 1. Now add everything. 0 plus K plus 2k plus again 2k plus 3k plus k square plus 2k square plus 7k square plus k equal to 1. Now find the k value from this. You might be getting a quadratic sometimes, and in that case if you get a negative value, please leave it because the probability will be negative through this. So if negative value comes, leave that k value, take only the positive values of k. Now after that, case 1 is done, we found k. Next is refill the k value in the table. Once you find what is k, you assume that you're getting k as 1 by 10. I'm not sure, it could be 1 by 10 or something. Assume that we are getting k as 1 by 10. So then refill the values in the table. Complete the table in the first place. Then answer the second subdivision. Second subdivision is P of x lesser than 3, which means P of x equal to 0 plus P of x equal to 1 plus P of x equal to 2. So add the probabilities of these events. That will be probability of x less than 3. Third case, P of x greater than 6. Greater than 6 means it's P of x equal to 7, P of x equal to 8, P of x equal to 9, and P of x is equal to 10. Add all the respective probability. 4, it's between P of 0 less than x less than 3. So it's between 0 and 3, not 3 or 0. So it is just P of 1 plus P of 2. So you can even write it as P of 1 or P of x equal to 1. It just means the same. So just write the probability and add it up. So this is how we do the 8th question. There is an oversight error here. The x values are defined only from 0 to 7, so 8, 9 and 10 won't come. So here x greater than 6 meaning only 7. In case if it is defined 10 to 10 only, you will write all cases. Otherwise it's only x equal to 7. So use only 7k square plus k value to write probability of x greater than 6. Number 9. A random variable x has a probability distribution given as this. In previous question, x and p of x is given in a horizontal form. Here it is in the vertical form. That is the only difference. Otherwise, it's pretty much the same only. So when x is 0, p of x is p of 0 is k. When x is 1, p of 1 is 2k. And when x is 2, p of 2 is 3k. That's what it meant. And for any other number, it is 0. Determine the value of k. Total probability is 1 always. So sigma, question number 9, sigma p of x equals to 1. So k plus 2k plus 3k equals to 1. 6k equals to 1. K will be 1 by 6. So let's complete the table then. So 1 by 6 when x is equal to 0. 2 by 6 when x is equal to 1, 3 by 6 when x is equal to 2 and 0 otherwise. Now B is P of x less than 2. Less than 2 meaning 0 and 1. So which is 1 by 6 plus 2 by 6, 3 by 6, 1 by 2. Then P of x less than equal to 2. So it will be P of 0 plus P of 1 plus P of 2. And then P of x greater than or equal to 2. Which is just P of x equal to 2 here. Because there is no other probability for any x value about 2. So only x equal to 2 value will be the answer. Probability distribution functions questions are over. Watch this video again and redo the sums. Thank you.